Everybody do the quad solve, 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 quad solve. Everybody listen, pay attention class. We're about to solve quad so that y'all can pass. We'll teach you 3 methods, X is what we're after. Start off first, watch.
Teach me how to factor.
Hey everyone, welcome to Big Ideas Chapter 3, 3.3 today. We're completing the square. We're solving quadratic equations. And today we're learning about how to complete the square. So we've already seen how to solve a quadratic equation using factoring, using square roots, where we take the square root of both sides and we don't forget to put plus or minus. And today we're going to be looking at now the completing the square, and then the next lesson we'll look at is the final way of solving a quadratic equation, which would be the formula. So as we get to this, let's go ahead and do a little cartoon first, a little Far Side cartoon. So a little alien invasion going on here. Inadvertently, Roy dooms the entire Earth to annihilation when, in an attempt to be friendly, he seizes their leader by the head and shakes vigorously. So the aliens apparently have hands for heads, and he mistook the head for a hand. All right, well, let's go on to our quadratic equations now. Okay, we're going to jump right into our extra practice on page 58. So this 1 through 3 says to solve the equation using square roots, and that kind of sounds like what we did in the last lesson, or actually 3.1, where it said to solve using square roots, but it doesn't look like what we were talking about, because when I was saying to solve it for square roots, that means it's missing the bx term, this term right here, that 4x, or like the 40t right here. So if it's missing that term, then you can do it that way. So like if we had an equation that said like x squared maybe plus 4 equals some number over here. It could be 0, it could be whatever. We can then solve for the x squared, right? This is what we did, is equal to like -4, and then we could take the square root of both sides. And that's what we were talking about. But now we have this trinomial here equal to some number. But the thing about this trinomial is it's special. Each of these trinomials here, this one right here, the t's right here all the way to 400, this one even over here, this one, all 3 of those are all called specially trinomial squares. So we can call them trinomial squares. And don't write all this down, please. I'm just going to do a little quick thing here, and then we're going to actually do the problems. So these are trinomial squares. You can put that on the side or something like that, that these are all called trinomial squares. You don't want to mess with what's underneath them, because we're going to go ahead and solve these in a second here. But as far as that's concerned, we need to realize these are special trinomials. They're trinomial squares, which means we can get them into a binomial square, which then we can take the square root of. And that's how we're going to solve these. We're going to change these trinomial squares, because trinomial squares can turn into binomial squares, or the square of a binomial, I should say, maybe like that, a binomial square, which would be like something like this. You have a parenthesis and a square like that, which you have your 2 terms here, your a term, which would be like the x term or something like that, and then plus or minus some number over here typically. So that's what we're going to be doing with these. We're going to turn these trinomial squares into binomials that are squared, so that we could take them to the square root of both sides to undo this square here. Okay, so now let's just try to work these out now. So I put a clean slate here, so that way you should be able to work these out now, 1, 2, and 3. We want to change this perfect square trinomial. And how do you know if it's a perfect square trinomial? Well, if this is a 1, 1's a perfect square, 4 is also a perfect square number. And so what you could do to check that is, if it's a 1 here, you really just only need to look at the 4 in the back, and you can see, okay, does the same number multiply itself to get this number and add to itself to get this number? So think of the number that multiplies to itself. 4 is 2 times 2. Is 2 plus 2 4? Yes. So that makes that a trinomial square right there, which means we can then factor it to a binomial square to using that number 2, using that special number that you multiply by itself and add to itself to get these numbers. So it's x plus 2. The plus sign is plus because this middle term is plus. So whatever sign is here, It's always going to be your sign here. And then we could say it's equal to 2. So now we have an equation that we can use square roots to solve. We can take the square root of both sides of that now. That undoes the square and leaves us with just x plus 2. And over on this side, we're going to have to take that plus or minus. Remember, we don't want to forget that step. Always when you take the square root of both sides, you have to include a plus or minus to account for the two answers. And so now the last thing to do to solve for x would just be subtract 2 from both sides. So you're going to subtract 2, and then you're going to get negative 2 plus or minus the square root of 2. Now that might look like a strange answer. And we know when we're talking about the answers to quadratics, we're always talking about their x-intercepts. And really that's always what we're talking about when we're dealing with any kind of equation, is we're looking for x-intercepts. So how does this, look like an x-intercept? Negative 2 plus or minus the square root of 2. Well, remember there's two answers and two places where it could go through x. So what we could do here is we could figure out what the decimals are. So on a calculator, we could figure out the decimal for this. If I did the square root of 2, that gives me a decimal there for that. And if I say, okay, it's positive, okay, so the positive one, and then if I was just to say minus 2, because I have a negative 2, so if I subtract 2, I would get this decimal, negative 0.586 perhaps, if I rounded to 3 decimal places. And if I did the same thing with the square root of 2, so I can get the other one, square root of 2 again, that's that number, but now if I make it negative this time, because it's a plus or a minus, this time if I make it negative, and then subtract 2 then, minus 2, I'm going to get another answer of negative 3.414. So let's go ahead, I'm going to just show you this on the calculator, that if we were to graph this equation here, that's where the x-intercepts would be, these decimals that I just showed you on the calculator. Let's go ahead and take a look at that. Okay, so here it is. I already typed it into the calculator. That was our equation right there. I just put it in the way it showed us on our problem. And here's what it gave me. And we can't even see the vertex because it's so far down. But we can see, here's the x-axis. Here's our x-intercept. So there's one right here. As you can see, it says right there negative, just like I did on the calculator, 0.586. And the other one for the x-intercept, negative 3.414. Those were the numbers that we got when we did the square root thing on the calculator and subtracted 2 from it. So that's how you can see that we can leave them in this form. So we could leave the form this way. It's more of a radical form. We don't have to get the 2 decimals all the time. Now sometimes it will require that, but if it doesn't require it, we can just stop short and leave it in a radical form. So that's what we're going to leave our answers all in radical form. But just remember, they do always mean those are 2 decimal answers that we can see the x-intercepts with. All right, so as we come to number 2, let's take a look at this one. We're going to see our trinomial square. We're going to change to our binomial square. Remember, 400 is a perfect square. And so what times itself is 400? That's 20. 20 times 20. So is 20 plus 20 40? Yes, which makes that a trinomial square. So we can then factor it to t minus 20. 20 is that special number that goes in here. And it's a minus sign this time because the 40 is negative. And it's going to equal 300. And we want to take down the square root of both sides to get rid of this square here. And so when we do that, we're going to have our t minus 20 now come out by itself. And now we got to just simplify this. It's going to be a plus or a minus, but 300 is pretty big. There's probably a perfect square in 300. In fact, we would notice that it's 100 times 3. The perfect square is 100, which the square root of 100 is 10. So we could now put plus or minus 10, which would be that square root of 100, and then after the 10, a square root of 3 still, because 3 is still going to be under the square root sign. So that's how we simplify it when it's too big. We want to get all the perfect squares that we can, the biggest perfect square, out of there, and leaving only something that's like a prime number in there that doesn't have any factors, or any perfect square factors, I should say anyways. And then the last thing to do is just add 20 to both sides. So when we do that, we're going to say t is equal to 20 plus or minus 10 square root of 3. Notice I'm putting the 20 first. Usually we put the plus or minus part second. So that's a good thing to do. And again, we could get 2 decimal answers for that, like I said. Now number 3, this one, how do we tell if it's a trinomial square when it's in this kind of form and it's got a 9 up in front? Well, now we don't just look at the 1, we have to look at both numbers. And we got to multiply, just like we did with the star technique, we multiply 9 times 1. That is 9. And we ought to make sure, definitely, that 9 and 1 should both be perfect squares, which they are. 9 is 3 times 3, 1 is 1 times 1. So you can multiply those together, which would give you 9. And then what times itself does give you 9? Well, the special number there would be 3. So does 3 plus 3 give us 6? Yes, so that makes this then also a perfect square. So now we need to put this one into a binomial just like we did here, but there's not going to be just w, it's going to be a number in front of w. And so that's what, for each of these, what times itself gives us these perfect square numbers. So obviously the 9 we said was the 3, the 1 was 1, 1 times 1 is 1. So those are the numbers that are going to go in our binomial. It's a 3w and a positive 1. So 3w plus 1 is going in the binomial. That creates that. You can always double check that. You can square this. It should give you the first one. You should square this one. It should give you the second one. And then you can multiply these together. That would give you 3w. And then multiply that by 2, times it by 2. It should give you the middle one. And then it's going to say equals the negative 18. We want to take the square root now of both sides. And so that's going to release our 3w plus 1. But then for this one, the square root of negative 18, there is a perfect square in this. We want to identify that. It's 9. And so we're going to put the negative sign with 9 because we're going to get an imaginary number here with this because the negative underneath this. So this is going to be, we're going to first put plus or minus. We can't forget that, to always include that. And then the square root of negative 9 would be 3i. So we're going to put that next. And then 2 would still be under the radical sign. So now it's the square root of 2. Now this time there's 2 things to do. We got to subtract 1, then divide by 3. So when we minus 1 from both sides, we're going to get 3w is equal to, put the negative 1 first, plus or minus 3i squared root of 2, then divide by the 3, so 3's cancel here, so now w equals basically this big fraction here. It's kind of an ugly answer, but that is it. So we can answer it this way, but there is another way we might want to answer it. In fact, the way they might want to on the big ideas as you enter your answer is separate this out into 2 kind of fractions. Don't make this one big fraction. So we could put the first negative 1 over 3 and put the second part also over 3. And so the other answer we could say would be negative 1/3, which would be the negative 1 over 3, plus or minus, and then these 3's would cancel over here, leaving you just with I squared of 2 on the other side of that. So that's another way to do that. Now with this one, where would the x-intercepts be? In fact, because it's a negative number here and we're getting an I in our answer, there are no x-intercepts. And I want to show you that also really quickly. I'm going to go ahead and graph this one. In fact, I might just graph one that's going to have a negative. We talked about one earlier that I'll graph really quickly and just demonstrate it that way for you. Okay, so here's a graph that says x squared minus 4, and you can see the parabola on here. You can see the x-intercepts. And that's because if I said if it's equal to 0, x squared minus 4, we would add 4 to both sides and take the square root. The answer there would be 2 and negative 2, plus or minus 2. But if I change this negative sign now to a positive sign, if I did that, oops, let me change it to a plus in here. There we go. So if I change this, there's our parent graph right there. If I just put plus 4 this time, now if I subtracted 4 from 0, if it says equals 0, if I put over here equals 0 like that, and I subtract 4, now it's a negative 4 on this side, take the square root of negative 4, that would be the 2i and negative 2i. Notice there is no graph. It's gone. It doesn't even exist because on the Desmos calculator, this is only going to deal with real numbers, not imaginary numbers. So this would be like on a different dimension, on an imaginary plane somewhere. That's where these answers would be located. So they do not have any x-intercepts on this one. So this would be y equals x squared, our parent graph, and notice it only has one x-intercept. And if we were to do what I did before with, if I said plus 4 back here, remember it's going to make this disappear, but we know that typically what would happen is putting plus 4 means that's going to be a vertical transformation. It would move it up here actually, and it would then be opening up here. Now it doesn't do that, as you can see. If I put plus 4, oh no it did, there it is. Yeah, it did that, there it is right there. So it does that, but notice it doesn't have any x-intercepts. So that's what you're seeing there when we do that. When I got rid of the y equals, it didn't even put it on here at all. But when I put the y equals in, you can see the graph. It is up there. It translates 4 units up, but notice it doesn't touch the x-axis. So that's why there's imaginary answers, because it's not going to touch and cross the x-axis. There's no x-intercepts. Okay, so on page 57, your vocabulary there, completing the square. This is what you want to write down for that. It says to add a term to an expression x squared plus bx. So this one doesn't say ax squared because you have to make sure your x squared is just a 1x squared plus a bx. So there's no c to it either. You can't have a c there because you're trying to get a new c number that would make this a perfect square. So that's what you're going to say, to add a term to an expression x squared plus bx to make it a perfect square trinomial. That is what we call the process of completing the square. And here's a little quick formula you can remember, b over 2 squared. So you can remember that, b over 2 squared. But remember, when you're doing b over 2 squared in an equation, I would highlight this. You're going to do that to both sides. You have to add that to both sides. So to complete the square for the expression x squared plus bx, add the b over 2 squared. But we're going to add that to both sides of the equation when you're going to solve an equation with this kind of method. So this kind of shows you the visual diagram of this. So if you have an x squared, there's your x squared plus a bx. You're going to basically take half the bx, and then what you'll do is you can bring this maybe down here, and then you're going to complete the square there. As you can see, you would be doing, to get that, you would do the bx times itself. Bx times bx would be a bx squared. Here's a little example of what I'm talking about. I think it might be more meaningful for you to see this. If here we have that, remember the 4 square box? We've done these before, where we're going to multiply 2 binomials together, right? So if my 2 binomials are exactly the same, x plus 3 this way, and I just start multiplying through, x times x, that's going to give me x squared. The 3 times the x for this one, that's going to give me 3x. The other 3x's over there, so both of these are 3x's. And then this one here is 3 times 3, which would give me 9. So if you have the same exact thing, just like it says here, x plus, this would be a positive here, x plus a b over 2, x plus a b over 2. They're exactly the same. If you do that and you multiply the same binomial times the same binomial, you are going to get a perfect square trinomial, because 3 times 3 would give us 9 here. And then we can, clean this up, right? We'd combine the like terms, 3x and 3x. So we'd end up getting x squared plus 6x plus 9. And we already know that this would be, okay, the special number is 3 here, because 3 times 3 is 9, 3 plus 3 is 6. And so you can change that to your binomial of just x plus 3 squared, because you're multiplying the same thing times itself. It can be written this way. Okay, so I found a little jingle that might help you remember to do this little step here of b over 2 squared, of the completing the square, to remember how to complete the square when you're solving an equation. So here I want to share this with you.
So this is how the song goes. It goes, and it's just a little jingle more than a song, but you half it, you square it, and you add it to both sides. You half it, and you square it, and you add it to both sides.
Okay, so it's just a little jingle, hopefully to help you remember how to complete the square. Half it, square it, add it to both sides. And what are you halving? You are halving the b term. So like in this case, if the x squared plus the bx, or 6x plus 9, you're going to half the 6. Half of that would be 3. You would square that, 3, which would give you the 9, and that's how you complete the square. You're completing the square with that number right there. 9 is the number that would complete your square to make this a perfect square trinomial. If you just have these first two, you could take the b number, half it, and square it, and then you can add it to this side, but you'd add it also to the other side as well as you're doing an equation. Okay, so back to page 58, 4 through 6, we're just going to get a little practice completing the square. It just says find the value of c. C would be that third term, so it's going to give you your first two terms, that like x squared plus the bx part. Now it doesn't need to give you x on these, it gives you y, s, and z. So the variable doesn't matter, but it's the same thing. It's the x squared plus the bx part, and we're trying to find out what is c. So we're going to use that, half it, square it, and add it. Those are the three things we're going to do. So for this one, And once we do figure out what c is, it says then write the expression as a square of a binomial. So we've already kind of done that a little bit, so we can be able to do that as well. So if we take the 14, that's our b number, we're going to half it. Half of 14 first would be, so half of it, negative 14. I'll make it negative as well. So negative 14 divided by 2, that's going to give us a negative 7. We then square it. So when we square that, negative 7, that's what our c number is. Our c number is going to be 49, and now we're going to add that to both sides, or well, not really both sides, because we don't have an equal sign here, but we're going to add it to this side and make that c 49. And so now it's just the 49's in there. We add it into this trinomial now to make it a perfect square trinomial, and then we can say, okay, remember 7 is our special number, so that's going to be the number going in. 7 times 7, 7 plus 7, so y minus 7 is the binomial, and then you square it, and that's it. All right, so go ahead and try, actually let's do 5, and I'll have you try 6. 5 is a little different because it has a 17, which is not an even number. So when we try to half of it, take half of 17, you could get a decimal answer right there, or you could leave it as a fraction. That doesn't matter. Now, typically, here's a little tip. I'm not going to have you, and I don't really do this ever myself, solve with completing the square method when this b number is an odd number. So I'm only going to solve with completing the square when it's an even number, because as you can tell, we're not going to get a nice number here. When we square top and bottom, that's going to give us 289 over 4. Or if we wanted to make that into a decimal and square it, that just gives us a bigger decimal number. We can add that in right there, 289 over 4 as the c, and then we can even do that here, 17 over 2, which is what was in here that we were squaring. That's going inside here, s plus 17 over 2. So again, I wouldn't use completing the square method to solve the quadratic equation for that. I'd use a different one. I'd probably use the quadratic formula that we'll learn next. So here's number 6. 24 is an even number. I'm going to let you try this. Go ahead and pause the video real quick and see if you can figure out what the c number is supposed to be, add it in, and make your square of a binomial. Okay, so hopefully you did that already. You got to take half of it, so 24 divided by 2, half it, which is 12, and then we're going to square it, so 12 squared is going to be 144. So that's what our c number is. We'll add it now to inside where c is, so now we can have a complete trinomial square. This is our trinomial square here. That's the square that we're trying to complete. It is a trinomial square, and not a literal square so much as a algebraic expression. And then we're going to make it a square of a binomial, so our special number there is 12. 12 times 12, 12 plus 12, and it is going to be positive because 24 is positive. So z plus 12, and then the squared. Okay, so now when we get to 7 through 12, it says solve the equation by completing the square. So now we have an equation, and we're going to need to complete the square. So what we're going to look for really is getting the first two terms by themselves, which would in this case on number 7 would be this r squared minus 6r. Getting those two by themselves, because this is not a perfect trinomial square with the way it is now, with 2 being here, because 2 obviously is not even a perfect square number. So to complete the square, we first have to move this c number, this negative 2, over to the other side to make room on this side for a new perfect square number to make this a perfect square trinomial. So we have to first add 2 to both sides. So that's going to leave this now by itself here, r squared minus 6r plus blank. We're going to make room for a new c number so we can do our completing the square step to do this. And now on the other side, we moved the 2 over here. We added 2. So if you add 2 to 0, you're going to get 2 on this side, and it'll be a 2 plus a blank. Remember, like I said, whatever you add here, you're going to add to the other side. It's just like regular, do whatever you do to one side, do the same to the other. So we're going to add it to both sides. So here's what we do. We take our b number, divide it by 2. So we got to figure what number is going in here. We've already done this. Half of this is 3, and then square it. That's going to gain 9. So 9 goes in here, which means that's the number we have to add to both sides. So we're going to add 9 to both sides. And now this trinomial square, we can now make a binomial square out of that, which we've done before as well. R minus 3 goes in here, because 3, remember, was the key number. 3 times 3 and 3 plus 3 gives us those numbers. So 3 goes in here. It's the special number, and the sign is negative. On this side we have 11, 12 plus the 9, and we're ready now to take the square root of both sides. So we'll take the square root of both sides, and now that will release our r minus 3, and now that r minus 3 will equal plus or minus. We have to remember that to put that first. Always include that plus or minus when you're doing this step of taking the square root of both sides. And then there are no perfect squares in 11, so it's just going to be plus or minus the square root of 11. And the last thing to do will just be to add 3 to both sides. So we will say r is equal to 3 plus or minus positive 3, because we'll add 3, positive 3 plus or minus square root of 11. All right, moving on to number 8. So again, the first thing we do is get these first two terms by themselves, and we do need to make sure that the x squared also is a 1x squared, which it has been here, or a 1r squared, whatever the variable is. We'll notice some of these don't have that, so we'll have to fix it. So starting with the x squared plus 10x, get that by itself, move this 28 to the other side, which means subtract 28. So that will leave room now. We'll put a blank here, x squared plus 10x, and we should actually put a plus blank, not a minus. Put plus blank. It's always positive back here. It's going to say plus in a second. And then negative 28 is on the other side, so it's negative 28 plus blank. You're always putting plus the blank. So now what's going to fill this blank in? Well, it's half of 10. So half this number. Always the b number is what you're going to half and square it. So half of that's 5. 5 squared is 25. So 25 is what goes in there. Yep, there's the plus now. So plus 25 there. It's kind of a weird looking 25, but there it is. And then 25 also on the other side. Oh, a much nicer one. And now we can change this perfect square trinomial, because 5 is that key number, that special number. 5 times 5, 5 plus 5. And so it's going to be x plus 5 now in the binomial. Remember, it's plus because the 10 is plus. So it's always going to get the sign of your b term here in the binomial. On this side, we take 25 away, and that's going to give us negative 3. So now when we take the square root of both sides, we know we're going to get an imaginary answer here because we're taking the square root of a negative number. And so when we do that, it releases the x plus 5 because it undoes this square. So it cancels it out. The square root cancels the square, and now leaves us with x plus 5. And then we got to make sure we include the plus or minus. But now with this 3, there's no perfect squares in it, but the negative 1, we want to take that out. We don't want to leave negative still under the radical. We want to change that to an I. So we're going to put I in front of the square root of 3. And now we just have to subtract 5 from both sides to be done. So x is equal to negative 5 first, plus or minus I square root of 3. And that's how we leave our answers. Remember, we can leave our answers in the radical form, especially when they're imaginary. We want to show that they're imaginary with the letter I. Okay, starting with number 9, it's a little bit different, but we see this little distributive property. We need to do that first. So y times y and y times 1. So that's going to give us a y squared plus y. And then we can put our plus blank. And it's equal to 3/4 also plus a blank. So if we were going to complete the square, we got to fill in something here. Now normally, like I said, if this is an odd number, I don't usually complete the square. And I want to do this one just to show you, why I don't typically do it with this way. We could do it a different way as well. In fact, I could get rid of my fraction right now by multiplying every term by 4, which would make this a 4y squared, a 4y, and make this 3. And then we can try factoring it and set it equal to 0 and see if it's factorable, which it actually is. If it's not factorable, then we could use the quadratic formula. So here's what we would do if I was going to do it with completing the square. So let's look at this. So if I say, okay, 1, remember our b squared over 2. b is 1. So it's 1 over 2 squared. And when you square 1, you square 2, you get 1/4. So we're filling in both sides. We're going to add 1/4 to both sides. So right here, it's going to make a binomial. Our special number is 1/2. 1/2 times 1/2 is 1/4. 1/2 plus 1/2 is 1. So it's y plus 1/2 in the binomial squared. And over here, 3/4 plus 1/4 is 1. And so now we would take the square root of both sides on this one. And we would end up undoing and canceling our square out. So it's just a y plus 1/2 is equal to plus or minus the square root of 1. We got to make sure we put plus or minus. And the square root of 1 is 1. So when we just subtract the 1/2 now from both sides, y is equal to negative 1/2 when we subtract 1/2 plus or minus 1. So we're going to get two answers here. If there's no radical, you don't want to leave it like this. You want to actually get an answer. So you'd say, okay, negative 1/2 plus 1, that's taking it away. It's going to be a positive 1/2. And negative 1/2 minus 1, that's going to be, like 3/2 really, or 1.5 on that one. So if you want to think of this as 0.5, you can. But basically the two answers would be a positive 1/2 and a negative 3/2, or positive 0.5 and a negative 1.5. That's our two x-intercepts. All right, let's move on to 10. Now 10 has a trinomial equal to 0, but what you need to notice about this, it does have a number in front, but that's a 2. Now you want to see, can I first quickly divide everything here by 2 evenly? So yes, because 16 and 6 are both even, everything can be divided by 2, and that means I could reduce this entire equation by just dividing every term by 2. So let's go ahead and do that. I'm going to divide every term by 2, put 2 underneath it. Even the 0 over here, you can do that too. So 2 divided by 2 will give you t squared. 16 divided by 2, that's going to give you an 8t here, a negative 3 here. 0 divided by 2 is still 0. So you get t squared plus 8t minus 3 equals 0. That's now a much easier equation, simpler equation to work with. Okay, so now the next thing to do is we want to get, just like we did up here, we want to get our t squared plus 8t by itself. We're going to add 3 to both sides. I'm just going to show it over here. I'm going to add 3 here, which means I'm going to cancel it here. So that leaves us with the t squared plus 8t, and we now have some room to put the plus blank. Always put plus blank to complete your square. On this side, 0 plus 3 is 3, so we're going to put 3 plus blank, because whatever we add here, we're also going to add to the other side. And so now we're going to figure out, okay, what are we going to fill this in with? So half of 8 is 4, and 4 times 4 is 16. So we're going to fill it in with 16. 16 is our new C number. That's what we add to both sides to complete the square. So our special number there is 4. 4 times 4, 4 plus 4. So it's t plus the 4 inside our binomial. T plus 4 squared is equal to 3 plus 16. That gives us 19 on the other side. So now we're ready to undo the square by taking the square root. So completing the square always uses square roots to eventually solve it. Just like we learned in 3.1, take the square root of both sides to undo a square. So when we're completing the square, we're getting it to a point where we can take the square root of both sides like we're doing now. And that way it undoes the square. T plus 4 can come out. And on the other side, we're going to see plus or minus. There's no perfect squares in 19, so it's just plus or minus square root of 19. We can subtract 4, so our answer here in radical form is just negative 4 plus or minus square root of 19. We could get 2 decimal answers for this. These would have 2 x-intercepts because it's not imaginary. They will have 2 x-intercepts. Another distributive property to do on number 11. So 3 times 2x first, that's 6x, and that's going to give us 30x here. So we're going to get a 6x plus 30x equal to negative 24. And let's see, okay, 6, if I can get rid of this 6, that'd be good. If I could divide everything by 6. And 36 does go into 30, 6 does go into 24. So I can divide every term here then by 6 to simplify this equation first. If that's not possible, if it doesn't work, then I wouldn't use completing the square. So in order for me to complete the square, 2 things have to be true, and that has to be where I have a 1x squared and I have an even b number. That has to be true. If those things are not true, then I'm not going to use this method. I'm going to use probably the quadratic formula that we'll learn in the next lesson. Okay, so back to number 11. We're going to divide every term here by 6. I'm going to put 6 underneath all of these. So that's going to leave this as an x squared. 30 divided by 6, this is 5x here. Negative 24 divided by 6, it's going to be negative 4 on the other side. So now we have this equation. And since 5 is an odd number, here's where I don't think completing the square would really be as nice as maybe just set it equal to 0 first, and let's take a look at it. So if I was to add 4 to both sides and set it equal to 0, it'll look like this. So because this is a 5, I don't want to use completing the square right now. That's why. It does have just a 1x squared, which is good, but this b number is odd. I don't like it when the b number is odd. So I'm going to add 4 to both sides, get it equal to 0. So now I see my trinomial. And so here's what you can try. You can see, is it factorable? Like this one on number 9 could have been factorable, and I could have found these using factoring. So can we factor this one? Are there 2 numbers that multiply to give you 4? That would add to give you 5. Well, obviously it's not 2 times 2 on this one. But 4 times 1 is 4, and 4 plus 1 is 5, so it is factorable. We can factor it to two binomials, x plus 4, x plus 1. So we can break apart with the simple method, x and x up front, and the two numbers were 4 and 1, and they're both the same sign because it's positive back here. They're both a positive sign. They're both positives in here. And then we can just use our zero product property, set each one of these separately equal to 0. So I'm going to subtract 4 on this one, so it's going to be x is equal to negative 4, and I'm going to subtract 1 for this one, so it's x is equal to negative 1. There's my two answers. So I thought that was a lot easier to get to the answers than using the completing the square when this number here, this b number, is an odd number. All right, number 12. I know this one looks a little more challenging, but first thing to do is, let's set it equal to 0. That's always a good thing. When you have a really kind of big quadratic equation, you have some x squareds in there, we have several like terms we're going to have to get together, it is best to probably set it equal to 0 and then go from there. That's kind of like your reset button. Reset it to equal 0, reset it to standard form, and that's always a good thing to do. So I'm going to subtract the 3x squared from both x terms here to bring the 3x squared over here. So now this will become just a 1x squared. I'm going to subtract the x as well from the x terms. So now I'm going to say negative 5x minus x is negative 6x there with the plus 28. And on this side now is 0. So now I have that. X squared minus 6x plus 28 equals 0. So that's kind of like reset now. I just reset this to standard form. Just hit the reset button. That's what you're doing. And now we can see, what should we do with this? Well, it does have an x squared here, and this b number is an even number. So this would be good. It's like one of these up here where it's good to use completing the square. I can move my 28 now to the other side and then complete the square here with this. And this is the same number as it was on number 7. So I'm just going to do that, and I'm going to fill this in here. So negative 28 now is over here, plus blank. I'm going to fill my blank in with 9. Remember, it's the same number here because we have a 6. Half of 6 is 3, so half it, square it, that's 9, and add it to both sides. So 9 on both sides then. And so now we can make this binomial down here same as this one. It's going to be, instead of r, we're just going to use x. So it's going to be an x minus 3 squared. And now over here, take 9 away from negative 28. We're going to end up with negative 19. And now we're ready for this, taking the square root of both sides. We're going to have an imaginary number, though, because this is a negative 19. We're taking the square root of a negative number. So we're going to undo the square. That's going to cancel. X minus 3 now is free. Over on the other side, we're going to always include our plus or minus. The negative sign is going to be the letter I to show that this is an imaginary number. So remember, don't ever leave that underneath the radical. Bring it out as an I. And then 19 just stays underneath the radical. The last thing to do is just add 3 to both sides. So it's going to say x is equal to positive 3, then this whole plus or minus part there. So x is equal to positive 3 plus or minus I squared of 19. All right, we're going to skip number 13 and go on to 14. So let's go to there. Hey, before we get to 14, let's do a little quick joke of the day. What lights up a stadium? What lights up a stadium? A soccer match. Yeah, just take out a soccer match. Light it up. Okay, so 14 through 17 says determine whether you would use factoring square roots or completing the square to solve the equation. So we need to start to make a decision on when we see any quadratic equation, we know it's quadratic because it's an x squared equation, that which kind of method, and how do we want to solve it. So sometimes some ways are better than others. So on 14, if we just say, okay, we got the x squared, we say plus 7x, it does have a bx term. So with this one, we wouldn't use the square roots because it has the bx term. Because it's a 7 there, that b is not an even number. I wouldn't even use completing the square. I would use factoring for this because you can just do a little quick factor out the x. So factoring is probably the best way to do that one. And if you factor out the x, because they both have x's in here, and then what's left inside here will be an x plus a 7. So x plus 7 is left there, and then we can take each of these two factors, the x and the x plus 7, do the zero product property to solve it. So x is equal to 0. There's one of the answers even. And x plus 7 equals 0. We just got to subtract 7 to find the answer there. So x equals negative 7. So quickly we can solve that one. That's a quick one to do. Number 15, it's got a binomial square equal to a number. So it's got some square equal to a number. So that's definitely square roots. You want to take quickly the square root of both sides to undo the square. Get rid of the square there. So we can do that. That will leave the x minus 1 now, like that, by itself. And we're going to always include the plus or minus. There are no perfect squares in 35, so it's just going to be plus or minus the square root of 35. Add 1 to both sides to finalize our answer. So you just add 1. So now these 1's cancel. X is on this side, 1 plus or minus the square root of 35 on the other side. We can leave it in terms of a radical if this is the case. If we need to get it to a decimal, sometimes we will, but we don't need to. We can leave it in radical terms. Now, number 16 says x squared minus 225 equals 0. So for this one, there is no bx. But we do notice that 225 is a perfect square number. So with this one, even if it's not a perfect square number, I should say you could have two options, and I think both factoring and square roots is about an equally good amount of doing it. We can factor it because 225 is a perfect square number. So I say yes, because 225 is a perfect square, we can factor this to two binomials because it's a difference of two squares. If you're not sure what that is, we will learn eventually what the difference of two squares is. On factoring those, that's kind of a special binomial with having a perfect square on each one and a minus in the middle. So those could be factored, or I think it's just easier, honestly, to do square roots. We could first add 225. So I'm going to use the square roots on this one, not factoring. If I say plus 225 to both sides, now x squared is equal to that 225. And then we can just quickly take the square root of both sides. So that leaves x now by itself, and it's going to equal plus or minus 15. The square root of 225 is 15, but we got to include the plus or minus on that as well. On 17, so for this one, we might not be able to decide just yet, but we do notice that 4 can go into 8 and it can go to 12. So we could reduce this entire equation by 4 first, then we might make a better decision about which kind of method we should use to solve it. So first, just simplify it. It's already in standard form, but it's not in simplest standard form. So let's first make sure it's in simplest form by dividing everything by 4. And so that's going to give us an x squared, a 2x here, and a 3. So we had x squared plus 2x plus 3 is equal to 0. Now we can see what we want to do. So since now, is it factorable? Can we factor this one even? Do you have two numbers that multiply to give you 3, which would only be 3 and 1? Do they add to give you 2? No, it doesn't work. If this was a 4, then it would have been factorable. So, or if it was a minus sign, it would have been factorable. But the way it is right now, it's not factorable, so we definitely can't use factoring. We don't want to use square roots, so we want to use completing the square because it does have a 2 here, which is an even number, and it's got a 1 here for the x squared. So definitely completing the square is the best method on this one. So we want to move the 3 to the other side so we can get the first two terms by themselves and make room for our new c terms. We're going to first subtract 3. That leaves the x squared plus 2x plus blank. So we have make some room for our new c term that we're going to add to both sides. So the negative 3 plus blank on the other side. So half of 2 is 1 and 1 times 1 is 1. So we're just going to fill that in with a 1 on both sides. This will now, the special number is 1 because 1 times 1 is 1, 1 plus 1 is 2. So it's a x plus 1 binomial. And we're going to put that as squared because there's 2 of them. When you're changing this to a trinomial, you always change it to a binomial squared, and it will equal on this side negative 2. So we can tell right now as we take the square root now of both sides to finish this off, we're going to get an imaginary number because of the negative 2. So the square root of both sides, this undoes the square, so x plus 1 comes out. Over here we have plus or minus to include, but we're going to make an I out of this. We're going to leave the 2 under the radical sign, but we're going to take the negative sign out and make that an I. So plus or minus I square root of 2. And then the last thing to do is just to subtract 1 from both sides. So x is equal to, after we subtract 1 from both sides, negative 1 plus or minus I square root of 2. There's our final answer. All right, we are getting closer to being done. I know we only have 3 more problems, but I know this is getting long and arduous. This is a long lesson. But we need to see these next 3 problems. The area of the triangle is 30. Find the value of x. So here's a triangle. It gives you some expressions there for the length and the width. or the base and the height, however you want to think of those. We'll use base and height for this one. So the area of a triangle is the formula base times height divided by 2. So your base, could be x plus 2. Your height could be 3x. So you're going to multiply those together and divide it by 2 for the area. Well, the area is 30. So we're just going to fill in 30 for A. So 30 will be A. The B, we can say is 3x. It doesn't matter. B times H or H times B. So 3x is going to get multiplied by the x plus 2. You multiply those two on top, and it's all divided by 2. So now at this point, we would want to distribute this 3x into here, and also we want to get rid of this 2. We want to multiply both sides by 2, so it's going to cancel the 2 out, and it's going to multiply 30 by 2. So if we do that first, we think about multiplying by 2, 30 times 2 is 60, so that's going to make it 60 now on this side. We can cross out that 2, and now it's going to give you 60 here when we multiply this side by 2. Multiplying this side by 2 gets rid of the fraction, and we'll just now distribute this. So 3x times x is a 3x squared, and 3x times 2 will give us 6x. Okay, so that gives us this quadratic equation. So now we need to solve the quadratic equation for x. And so for this one, we notice that the 3 is the number in front of x squared, and 3 can go into 6, and 3 can go into 60. So we want to reduce this all by 3. So definitely you can do that. If you want to set it equal to 0, you also can do that to kind of reset it. But we don't really have to. You don't need to necessarily. You can think about, I'm just going to divide everything by 3 to make this smaller. So that's going to make 20 now on this side. This will now be just the x squared. 6 divided by 3 is 2x. And you already kind of have it set up for completing the square because you have your x squared and your bx term on one side by itself. It's got room even behind here to add in our c, and that c is going to be the same number as it was here. You see how we have the same thing, x squared plus 2x? We're going to add in 1. So we're going to put plus 1 to complete our square, and remember we're going to add it to both sides, so we got to add it to the 20 on the other side. So now that makes 21 on that left side, and now this can become the same binomial, x plus 1 squared. So the x plus 1 squared will be there. We'll do the same thing, take the square root of both sides. This one's going to be not imaginary because it's positive 21, so it's a real number. And so when we take the square root of both sides, it undoes the square. It has our x plus 1, and we're going to have plus or minus the square root of 21. Now, for that, plus or minus the square root of 21, there's no perfect squares in that, so we can just leave it alone. In fact, since we're not even... we can't really leave this answer. It says find the value of x. To find the value of x, we don't want to leave it in terms of a radical. We actually want to find what is the value of x, because a plus or a minus means there's a possibility you might have a negative answer. And obviously, the value of x can't be negative, otherwise you have a negative length, and that doesn't work. So that would be considered what we call an extraneous answer because it's not going to work. So in this case, we need to change our square root of 21, just using a calculator, to a decimal. So the square root of that's 4.58 if we go to 2 decimal places. And so we're going to end up seeing that over here. So I'm going to see, okay, x. So when I actually subtract 1 from both sides, here's the way we should see this. Now, x is actually equal to negative 1 plus or minus the square root of 21, which is now going to become this decimal. So I'm going to change the square root of 21 to that decimal. So it's going to be negative 1 plus the decimal. So we can show that. Negative 1 plus 4.6. I'm just going to round it to 1 decimal place. And then it's negative 1 minus that decimal. Negative 1 minus 4.6. So our answer is here for this one. If I take 1 away from 4.6, I'll get 3.6, and this would be negative 5.6. So obviously we can't keep the one that's negative. The answer can't be negative, so we're only going to keep 3.6. So our answer, find the value of x, it is 3.6. So that's our answer on this one for number 18. All right, let's go on to 19. Okay, so now problem 19 is going to show us how we can use completing the square to change a standard form quadratic equation into our vertex form that we used to graph with. So that's our graphable form, which would be like, a parenthesis x minus h, squared plus k. So we can change it by completing the square. So here's what we'll do first of all, f of x, we need to realize that is our y. So we're going to say y equals, but I'm going to leave some space between the y and the equal sign because I'm going to complete a square and I'm going to have to add some number to the y as I'm completing the square. And now we have our two first terms, your x squared and your bx term. Let's put those down first, just the x squared plus the bx. And we want to leave some space to complete the square with these two. So I need to put a little plus blank now in front of each of these. So the plus blank on this side, plus blank over here too. So I'll leave some space there. I want to put this into a parenthesis. So this is where it's going to be in a parenthesis here. Let's put that in a parenthesis, and then we can put the plus 22 in the back behind there. That would be where our kind of k number will be. So now we want to think, okay, about what we're going to use to complete the square. Well, we know to half it, square it, and then add it, right? So half this b number, so that's 3. 3 squared is 9, so we're going to add 9 into both sides. So we add 9 to this side, we add 9 to the other side. Now we can change this into our binomial squared. So we can see our y plus 9 on this side, and then our binomial squared is going to be remember our special number is going to be 3. 3 times 3, 3 plus 3, so x plus 3. It's plus because it's a 6 is plus here. And then our plus 22 is still behind that. So now the last thing to do is just solve for y by subtracting 9 from both sides, and we'll have our vertex form. So once you cancel there, it's going to say y equals the x plus 3 squared, 22 minus 9, that is 13. So there's our vertex form, y equals x plus 3 squared plus 13. There, the a number would still be 1, which is the same shape as the parent graph. H is negative 3. And the k is 13. It does say identify the vertex, so negative 3 comma 13 is the vertex there, h comma k. And it's always opposite for h when you pull that out. And then k is the same thing. So this can be helpful and used for when you're graphing a standard form quadratic equation and you want to use vertex form to graph it. You can use this and change it into vertex form to make it maybe a little bit easier to graph that parabola. Okay, so our last problem, number 20, about this golfer. There's a picture of Tiger Woods there. A golfer hits the golf ball in the fairway with a velocity of 80 feet per second. The height, h in feet, of the golf ball, t seconds after it is hit, can be modeled by the function, and it gives us this quadratic function here. Letter A says find the maximum height of the golf ball. So what we need to do is we need to actually find, this would be a parabola. Remember, the golf ball is going to go up and then come down back to the ground. So what's the maximum height there? That would be the vertex. We need to find the vertex of the parabola that's of this. So it'd be good if we could, we could find the vertex a couple different ways. But one way we can do it, and let's do it this way since we've been talking about completing the square. Let's change this into vertex form so we can identify the vertex. So use completing the square to do that. So again, we're going to have our h of t here. I'm just going to say h though. So h plus blank. I'm going to use I'm adding whatever I add to this side. I'm going to add also to the other side. So I'm putting a plus blank here. Is equal to, now here's a problem. We have a negative 16 right there. Now we got to think of these first two terms here as a unit. These first two terms, the t squared and the t term here, as together, and then this is going to be moved back. So I'm not going to change this at all, but I do want to factor out a negative 16. Negative 16 can come out of 80. So I'm going to factor negative 16 just out of these first two. So that leaves me now with a positive t squared minus 5t, because negative 16 times 5 or times negative 5 would give us positive 80. Or 80 divided by this negative 16 is going to be negative 5t. Then we can put our plus blank to fill in our c here, our new term, to make this a perfect square trinomial. And then we can put our plus 0.1 at the end of this. Okay, so I know this is an odd number here. I don't really like completing the square with it, but let's just do it anyways on this one. So in order to do that, we have to half this. Half of 5 would be 2.5. So we can do it in a calculator here. So we can say 5 divided by 2 is 2.5, and then square that, multiply it by 2, it's 6.25. That's what's going to go in right there, 6.25. Now, the difference, though, is that we're not going to put 6.25 over here because we have a negative 16 outside of this parenthesis with that 6.25 in it. So you have to distribute that negative 16 to 6.25. You got to multiply negative 16 times 6.25. So if I say times 16 here, that's going to give me 37.5. So 6.25 times 16, I put times 6. No wonder it didn't look right. 6.25 times 16, there we go. 100, so it's going to give us 100, but it's going to be negative since it's negative 16. So a negative 100 is going to actually fill that blank in. Okay, so we can change this now to a binomial square. So h minus 100, I'll just change the signs there to a minus now. It'll be the negative 16 up in front, and it'll be t minus 2.5. Remember, 2.5 is a special number. That times itself is 6.25. Adding to itself is 5. 0.1 is behind here. Last thing to do is just add the 100 to both sides, so I'm adding it to this 0.1. So when I do that, h is now going to equal the negative 16 t minus 2.5 squared plus the 100.1 when you add those together. So now we can identify our vertex is h, which is 2.5, and there's our k number, h comma k. So 2.5 and 100.1. The maximum height is always your y number here of the vertex. So it's 100.1 feet. There's our answer for A. B says, how long does it take the ball to hit the ground, which means h would be 0. So how long does it take for this h to be 0? Here is going to be 0 right here, or you can make it 0 here. It doesn't matter. So if we left it like this, in this form, making this 0, what we could do then is we could subtract 100 from both sides. So now I have negative 100.1 and 0. So I have negative 100.1 on one side. On this side I have the negative 16 first, so we would want to divide both sides by that to get this by itself. So now I have t minus 2.5 by itself if I divide my negative 16 out. And I'm going to divide this now by negative 16. So that's what I have over here, negative 100.1 divided by negative 16. So now I need to do this on the calculator. So I'll just use, it's going to be positive, so 100.1 divided by 16, that's going to equal 6.25. Let's just call it 6.25, I think. So 6.25 equals this binomial squared. Take the square root of both sides. And when I do that, I'll find out I'll get 2.5 is equal to t minus 2.5. So we're going to add 2.5 to both sides. That's going to give us 5. So t equals 5. So how long does it take for it to hit the ground? 5 seconds, because it's in t seconds right there, right? So we're going to use seconds here. 5 seconds is the answer. All right, so there's the final problem, our final answer, and you're ready for your assignment. And I'll see you on the next lesson.